Question 1 is just a straightforward arithmetic. Using BODMAS, this simplifies to 10 plus 10 times 10 is 100 times, in the bracket is 20. So that's going to be 10 plus 100 times 20 is 2000. So the answer is 2010. Question 2 says 3 of the interior angles of a given quadrilateral are each 80, so we've got 80, 80 and 80. That's going to be 3 times 80, which is 240, and you know that a quadrilateral, a four-sided shape, always has 360 degrees, so you take that away and you get 120, which is A. Question 3, exactly one of the following is a prime number. Which is it? I'm going to do this by elimination. First of all, I can go and say, well, it's not B because it's an even number and primes aren't even, and it's not D for the same reason. So I've knocked out even numbers. After multiples of 2, the next obvious one to do is multiples of 5. This one ends with a 5, that's clearly a multiple of 5, so it's not prime. Then we're left with 2 numbers. Next obvious one would be multiples of 3. Multiples of 3 are easily identified because their digits add up to a multiple of 3. So if we add up the digits to this one, I get 2, and that makes 5, that makes 9, 14, 20, 27. 27 is a multiple of 3, so this doesn't count either. That leaves us by elimination answer E. If I wanted to be sure, I would just quickly go and add up those digits and make sure that didn't come out to a multiple of 3 also. That would be verification that I haven't made a mistake somewhere here. Question 4. A radio advertisement claimed that a particular brand of artificial sweetener every day would save 7,000 calories in a year. Approximately how many calories is that per day? Well, it's 7,000 divided by 365. That's a difficult calculation to do, so it says approximately, so I'm just going to do 7,000 divided by 350, because effectively that's the same as 700 divided by 35, and 70 divided by 35 is 2, so 700 divided by 35 is 20, which is answer A. Question 5, which is the following has the greatest value? I think just quickly work these out. So that's going to be half of 25 is half times. Sorry, 1/25 is half times 1/25, which is 1/50th. This one here is going to be 1/5 times 1/10, which is also 1/50th. This one is going to be 1/3 times 1/20th, that equals 1/60th. This one, 1/6 times 1/5, that's going to be a 30th, and this one is 1/4 times 1/15, that's going to be a 60th again. I can't be those two because they're the same. This one is going to be, this one is the smallest, so the answer is E. Question 6, in a triangle PQR, S is the point on QR such that that is that and that is that. 20. What's the size? I'm just doing it by the diagram. That's clearly an equilateral, an isosceles triangle. That means this one here must be 20. And this angle here, those two add up to 20. They must all add up to 180, so that must be 140 in there. And since this is a straight line, this one in here must be 40. That means this one here, since that's an isosceles triangle, must also be 40, and this one up here must be, those two are 40, that must be 100. I've actually not read the whole question, I've just labelled all the angles straight away. A bit of a waste of time perhaps, anyhow. Size of angle from P to R to S. So P is there, R is there, and S is there, so it's that angle there. This is the angle we want. I've worked it out to be 40, which is answer C. The Three Choirs Festival is held annually. Its venue rotates in a 3-year cycle among Hereford, Gloucester and Worcester. In 2009 it was held in Hereford, that's 2009, it was Hereford. In 2010 it will be held in Gloucester. 2010 Gloucester. Next year it'll be Worcester, so that's 2011 Worcester. Assuming this 3-year cycle continues, which one of the following years will it not be held in Worcester? The key here is multiples of 3. You've got a 3-year cycle for 3 towns. The one which is held every multiple of 3 is Gloucester. That's the one I'm going to look at. If I can go and find out when it's held in Gloucester, Worcester is going to be the next year. So in fact I'm going to take away one from each of these to make this 2019, because if 2019 is a multiple of 3, it'll be held in Gloucester, which means that 2020 will be Worcester. Now 2019, the digits do add up to 3, so that is going to be held in Gloucester. And so 2020, which the question has, is the next one, which is Worcester. Let's do the same here. Let's have a look at 2031. Digits add up to 3, that makes it Gloucester, so the year in the question is Worcester. Here, 2046, those digits add up to 3, so that's in Gloucester, which means this one is Worcester. These, it's 2053. Adding up those digits, 2 plus 5 is 7 and 3 is 10. Now that's not a multiple of 3, so in 2053 it's not held in Gloucester, which means in 2054 it will not be held in Worcester, so that is our answer. On my clock's display, the time has just changed to 2:31. How many minutes will it be until all the digits 0, 1, 2, 3 next appear together again? Well, you can make 2:13, but that time has already passed, so the next time is going to be 3 something, so it's 03, and we've used those. We've got the digits 2 and 1. Obviously it's not 2 and 1 because 1 and 2 will be sooner, so the next time is going to be 3:12. The question goes and says how many minutes until they will appear again, so we've got to work out the time difference between 3:12 and 2:31, so that's going to be 29 minutes to get to 3 o'clock plus the 12 minutes there. That's going to be 41 minutes. With question 9, the perimeters of these 3 shapes are shown and made up of straight lines and semicircular arcs of diameter 2. They will fit snugly together in a jigsaw. I can see they will fit together. What is the difference between the total perimeter of the 3 separate pieces and the perimeter of the shape formed when the 3 pieces fit together? Well, when the 3 pieces fit together, that's going to join there, so that won't exist. That's going to join there, that won't exist. These parts will join together, so in effect we're going to lose the parts I've highlighted there. This is a unit 1, that's unit 1, that makes 2, that's going to be 3, 4, 5, 6, 7, 8, so there's 8 straight bits, looking like it could be that. Let's check the curved bits. This bit and this bit make a whole circle, and that bit make a whole circle. So that's 2 whole circles. Now the formula for circumference of a circle is 2 pi r. So the r is, well, the diameter is 2, so the radius is 1, so that's going to be 2 pi times 1, so that's 2 pi. But since there's 2 circles, it's going to be 4 pi, so our answer is 8 plus 4 pi, which is C. Question 10. 1 year in the 1990s, January 1st fell on a Monday. 11 years later, January the 1st was also on a Monday. How many times did February the 29th occur in those 11 years? I think this question was meant to use more complicated maths than I'm about to use. I'm just going to say, well, leap years are every 4 years, when they're a multiple of 4. So leap years were in 1992, 1996, 2000, 2004, 2008, etc. But we're talking from 1990 and 11 years later. So that's going to take us to 2001. So it's actually just those years which come in between, and that's 3 of them. Right, question 11. You eat more than I do, said Tweedledee to Tweedledum. That is not true, said Tweedledum to Tweedledee. You're both wrong, said Alice to them both. You're right, said the White Rabbit to Alice. How many of the 4 statements were true? Let's have a look at the first two. The first two contradict each other. You eat more than I do, and that is not true. So only one of those is true. The other one is false. So one of those is true. We don't know which one. You are both wrong, said Alice. Well, from what I said before, they're not both wrong. One of them's right and one of them's wrong. So this one is false. You are right, said the White Rabbit to Alice. Well, that must be false as well, because the White Rabbit is saying that Alice is right, which says they're both wrong. So that's a false statement as well. So we've got 2 false statements and one of these which is false and one that's true. What are we looking for? How many of the 4 statements are true? It's just one of them. That's B. Question 12. A cuboid is cut away from a cube of side 10 as shown. By what fraction does the total surface area of the solid decrease as a result? Now that's an interesting one, because we had a surface area around the outside here. This top has lost half of its surface, but we've actually gained surface area on the actual cuts themselves. So the amount of area lost from the top has actually been replaced by this, so there's no net loss there. And also this bit on the side, there was an area lost on the side here, but it's been replaced by where the cube was actually cut. The only bits that are missing are actually a square cut out of the front there and a similar square cut out of the back. So we're missing 2 squares. Now how many, we want a fraction, so how many of those squares would be on a whole cube? Well, the whole cube, each face would have 4 of those squares, and there's 6 faces in the original cube, so that's 4 times 6 is 24. So it's 2 squares out of 24 possible are missing, which is 1/12, which is D. Question 13. At Corbett's Ironmongery, a fork handle and candle cost a total of £6.10. Let's use F for fork handle plus a candle. That costs £6.10. The fork handle costs £4.60 more than the candle, so that means the fork handle is the candle's cost plus £4.60. I can substitute that in, that's simultaneous equations. I'm going to rewrite this equation, but instead of F I'm putting C plus, so that's going to be C plus 460 in place of that F, plus the C, that equals £6.10. That means 2C must equal £6.10. Take away £4.60, which is £1.50. So that means that C, the cost of that is 75p or 0.75. And if the cost of C is 0.75, that means that F must be 0.75 plus £4.60, so that's £5.35. The question actually asks what's the cost of 2 fork handles, so that's 2F plus 4C, so that's 2 times 0.75 added to 4 times £5.35, and if we work that out it comes to £13.70, which is B. Question 14. given that 4x minus y equals 5, 4y minus z equals 7, and 4z minus x equals 18, what's the value of x plus y plus z? Now we could solve those equations, I think, but there's 3 simultaneous equations. That'd be pretty tricky. I've just got a gut feeling about this. I'm going to add them all together. I'm going to do the 4x minus y plus the 4y minus z plus the 4z minus x, and that's going to equal the 5 plus the 7 plus the 18. 5 plus 7 plus 18. Now that comes to 30. Now if I look at this, I've got a 4x and I'm taking away an x, which leaves me 3x. And I've got a 4y there, I'm taking away a y there, gives me 3y, and I've got 4z, take away z, so that gives me 4z. So effectively that is 3 lots of x plus y plus z, which equals 30, so just an x plus y plus z must be 10, which is answer C. Question 15. Bill is trying to sketch the graph of y equals 2x plus 6, but in the drawing the axes is placed x-axis up the page, y-axis across the page. Which of these 5 graphs is correct sketch? If I use the y equals mx plus c, then c is 6. This is the first one I'm going to use. C is 6. So instead of it cutting the vertical axis on 6, it's going to cut the horizontal axis on 6. It doesn't there, so that's wrong. Doesn't there, that's wrong. Doesn't there, that's wrong. It only cuts them in one place. That means the answer is E. I did that purely by saying that the intercept must be 6. It's usually 6 on the vertical axes, but since they've been interchanged, it's 6 on the horizontal axes. Another way to do that would be to rearrange the equation. If we started off with y equals 2x plus 6, but x and y has been interchanged, we could actually use x equals 2y plus 6. X and y have been swapped. Now if we rearrange that, swap them around, so we get the 2y plus 6 equals x, which means that 2y equals 6 minus, sorry, x minus 6, and that means that y equals half x minus 3. So we could look for that graph, as it were. So the half x minus 3, slope of half minus 3, that's the only one that cuts at minus 3 with a slope of half x. So again, it's E. Question 16. Albert Einstein is experimenting with 2 unusual clocks which both have 24-hour displays. One clock goes at twice the normal speed, the other clock goes backwards, but at the normal speed both clocks show a correct time at 1300 hours. What is the correct time when the displays on the clock next agree? Now I'm not going to use any clever maths for this one. I'm just going to do a modelling situation. I'm just going to say, okay, they both start at 1300 hours. And then after 1 hour, let's put them both at 13, after 1 hour the first clock has moved on to 15, added 2 hours, and the other clock has gone back 1 hour. And after another hour, after 2 hours, this clock's gone back another hour to 11, and this clock has gone forward to 17. Now I'm just going to keep on doing that. For 4 hours, 5 hours, 6 hours, that's going to be 11, 10, 9, 8, 7, 6, etc. This one's going to be 17, 19, 21, 23. From 23, that's going to go past midnight to 1 o'clock again. And that's going to be 3 o'clock. They haven't agreed at the moment, so I'll just carry on up here. So that one goes from 6 o'clock to 5 o'clock, and this one goes to 5 o'clock as well. So that has taken 1, 2, 3, 4, 5, 6, 7 and 8 hours for them to both agree at 5 o'clock. Obviously that's not the time because it started at 1 o'clock in the afternoon, plus 8 hours, that's going to take you to 2100 hours, which is answer E. Question 17. Last year, Jill's cylindrical 21st birthday cake wasn't as big enough to feed all her friends. This year she will double the radius and triple the height. What will be the ratio of the volume of this year's birthday cake to the volume of last year's? Now this is a cylindrical birthday cake. You need to know the formula for a volume. Formula for volume is the area of the cross section, which is pi r squared, times the height of it. Now she is going to double the radius, so the radius is going to become bigger by 2 squared, because this is an r squared, so it's getting bigger by 2 squared, and the height is increasing by 3. So the volume is actually increasing by 2 squared times 3, which is 4 times 3, which is 12. So the ratio is going to be 12 to 1, which is A. Question 18. Supergran walks from her chalet to the top of the mountains. She knows that if she walks at a speed of 6 miles an hour, she'll arrive at 1, whereas if she leaves at the same time and walks at 10 miles an hour, she will arrive at 11 AM. What speed should she walk if she wants to arrive at 12 noon? This is a distance time problem. For a distance time problem, you've got the formula V equals distance over time. Speed or velocity equals distance over time. That's the formula that you need to use for this one. Since the common thing is distance here, she's always walking the same distance, I'm actually going to use it in the form D equals V times T. Now if I draw a model of her situation, this here, she's leaving home, if we call that at time T, she's travelling this distance. She would make this a timeline, so she's travelling here and she gets there at 1300 hours if she's doing 6 miles per hour. And then if we have the same time, she travels and she gets there at 1100 hours if she does 10 miles per hour. Now if I go and use this formula here, distance equals V times T, I've used capital T here to represent the starting time. Little t is going to be the time it actually takes. So with this first one here, the first one can be distance equals V, which is 6 times the time. I'll do it over here, I think. 6 times the time it takes, that's 13 take away the starting time. 13 take away the starting time. Now since that's the distance for this second diagram is exactly the same. So it's going to equal V times this t, which this V is 10, times the time taken here is 11 take away the starting time. That's like solving a simultaneous equation. Now I'm going to multiply out that to give me 6 times 13, which is 78, take away 6t equals, that's 110, take away 10t. Now if I bring the 10t there to minus 6t equals 110 take away 78, that gives me 4t equals, that's 32, so t equals 32 over 4, which is 8. So the starting time is 8 o'clock. So I can replace that with an 8 o'clock. So I know the starting time. I'm going to use this first, I'll use the second diagram, either one of those diagrams, since this is down here. I can now, once I know the starting time is 8, I know this time, total distance here is 3 hours. And so the distance equals the time, which is 10, times the 3 hours it takes them. So that's equals 30. So now I know that distance equals 30. I can now have a third diagram for what I want, where I leave at 8, I want to arrive by 12 o'clock, and I want to know the speed. So if I use this formula back up here, V equals D over T, I'll do it over here because I'm running out of space. So V equals the distance. I know the distance, we've worked it out to be 30, over the time. The time it's got to take to get there by 12 is 4 hours, so it's 30 over 4. That equals 7.5 miles per hour, and that corresponds with answer A. Question 19. A snail is at one corner of the top face of a cube with side length 1 meter. The snail can crawl at a speed of 1 meter per hour. What proportion of the cube's surface is made up of points which the snail could reach within 1 hour? Wow, let's draw a cube first. I'll do it isometrically. There's my cube. Well, not a very good cube, but nonetheless a cube. Let's imagine the snail is at this position here. The snail can crawl 1 meter per hour, which is the same as the length of one edge of the cube. So the snail could crawl to that place, it could crawl there, it could crawl there, and in fact it could crawl anywhere in a arc of radius 1 meter. So it could actually crawl anywhere in there. It could also crawl anywhere in that arc and anywhere in that arc. There's 3 arcs of 1 meter in which it could crawl. So if we find the area of that and compare it with the area of the whole cube, so the area of one of those arcs, that's pi r squared. Area equals pi r squared. R is 1, so that's just pi. But it's only a quarter of a circle, so it's pi r squared over 4. So that's pi times 1 squared over 4. It's just pi over 4 for each of those. But there's 3 quarter circles, so that's 3 pi over 4. Now if we compare that with the whole cube, the area of the whole cube, it's sides of 1, so each face is 1 times 1. And there's 6 faces, so that's 1 times 1 times 6, that's 6. So we compare that with 6, so we divide that by 6. If you know your fractions, that's going to be 3 pi over 4 times 1 over 6, which comes to 3 pi over 24, which equals pi over 8, and that corresponds to answer B. Question 20. Shahbaz thinks of an integer n such that the difference between square root of n and 7 is less than 1. How many different possibilities are there for n? So the difference, that means we subtract them. So we subtract n and 7, and that is less than 1. Well, it could be that you get a negative answer, so it could actually be greater than minus 1. That's the way I would write it. The difference between n and minus 7, so if n is, the square root of n is bigger, then n minus 7 is less than 1, but if the square root of n is smaller than 7, the answer is going to be greater than minus 1. So now we can solve it like a 3-part inequality. If we go and add 7 to each one of those 3 parts, so we add 7 here, we get 6 is less than the square root of n is less than, adding 7 to that gives us 8. And now we can square all parts. So square this, we get 36 is less than, square that we get n, and square that we get 64. So n is between 36 and 64. It's not going to be equal to them because it's not got the equal bits in the inequality. So effectively n can be 37, 38, and all the way up until 63. And if you go and count those up, you get 27 values. And that corresponds to answer D. Question 21. A square maze has 9 rooms with gaps in the walls between them. Once a person has travelled through a gap in the wall, it then closes behind them. How many different ways can someone travel through the maze from X to Y? So here's our maze. How can we travel through it? Well, the obvious way is we start at X and we just go across and down to Y. Now clearly they're saying 8 ways or 10 ways. There's a lot of them. I'm going to actually just draw out lots of copies of this maze because I'm going to get confused if I do it all on that same diagram. I suppose I could use different colours. I'm just going to draw out one copy of the maze very quickly for each one of those. Incidentally, I can make it easy for myself because here, if I go across this way and down, I'm going to get the mirror route by going down and along. I'm only going to consider routes where I start going across, because each route I find that starts going across to this square here can be mirrored by going down to this square here. So I'm only going to consider this way, and then I'm going to double it. So let's draw out some grids. I'll just draw them as cross noughts and crosses grid. So we've done X to Y that way. My second one, I'm going to go across, and down. That's 2. Let's draw another grid quickly. I mean, this is question 21, so it's worth taking our time here. We're going to go across, down, and across. I don't want to make mistakes. I'm not going to answer this unless I'm pretty sure. Well, I really want to be absolutely sure. What can I go next? I'm going to go with across and down. I can go back, down, and across. So that's my fourth one. See if I can do another. I can do another one similar to that I've just spotted. So that's my X and Y. I can go for my fifth one. I can go across, down, across there, and in. This is looking good. Well, now I've got 5 different ones here, and if I double that, I get 10. So I know that A can't possibly be the answer. That's quite useful. I already found more than A. Right, can I get a 6th one? If I get a 6th one, I think I can go across there, down, back, and into there. That's 6, so I know there's at least 12, so B can't be the answer. Let's draw my next grid down here. See if I can find the 7th. I'm not happy of submitting my answer as 12 yet because there's 3 to choose from still. Can I find the 7th one? Yes, I can go across there, down there, into that corner this way, back up there. I can go back into this square here because I haven't been through this door here, so it's not closed. So I can go back into there and I can get out. No, sorry, I can't do that one. Can I? Yes, I can, and I can get out this way and go down. You see, I've only gone through each opening once, so that's my 7th one, so it can't be answer C, so I know it's going to be D or E. It might be, if I can't find another one, I might take a guess at 14, but I'm going to try and find another one. If I have a think about it, from X, going through that centre square was an interesting one. Yes, I can go down there, all the way down. Now I've gone through that door and that door, so those are closed now, but I can go back here and I can come back through those side doors. Yeah, these top and bottom doors are closed, but these side doors aren't, so I can go zooming through the side doors and back into there. That makes 8, so I know it can't be D, so the answer must be E. I'm not even going to bother looking for more. There's no more in the question. Question 22. Curly and Larry like to have their orange squash made to the same strength. Unfortunately, Mo has put 25 millilitres of squash with 175 millilitres of water in Curly's glass and 15 millimetres of squash with 185 millilitres of water in Larry's glass. How many millimetres of a mixture in Curly's glass must be put into Larry's glass so that they end up with drinks of equal strength? Now this is actually a trick question, and I'll show you why. If we start off with Curly, Curly has a ratio of squash to water of 25 to 175. And then we have Larry. His ratio of squash to water is 15 to 185. Now I'm just going to cancel them down to a ratio of 1 so we can compare them. This one will cancel down to 1 to 7. And this one will cancel down to 1 to 12 and a bit. So this is the stronger one, and the question's asking how much of this one do I have to pour into this one to get them of equal strength. And it's a trick question because when I pour some out of this glass, this ratio will always stay the same. Yeah, the stuff in the glass will remain at 1 to 7. But when I pour this stronger drink into Larry's, Larry's will get stronger, but it will never get to 1 to 7. It can't be, because the 1 to 7 ratio that's of the pouring in drink is going to be diluted by the 1 to 12 or 1 to 11 or 1 to 10, whatever it becomes, of Larry's. The answer is it's not possible to get the drinks of equal strength once they've already been made. So it's E. Question 23. The diagram shows a pattern of 8 equal shaded squares inside a circle of area pi square units. What is the area in square units of the shaded region? Well, the first thing we know is the area of the circle is pi. Now the formula for the circle is pi r squared, so it means that r equals 1. So if r equals 1, let's say from the centre here, this is a bit of a trick, but from the centre here, every single distance is 1 to the circumference. Now the one that I'm most interested in is from the centre right to the edge where it touches a square. So I'm going to draw that one there. Now this bit here must also be the length of a square. Let's call the length of a square x. I'm going to get a triangle here. That's going to be x, the side square, and this is going to be 2 squares, that's 2x. Let's just copy it out so you can see where I'm coming from. That's x, and that must be 2x. X is the height of the square. And we know this is 1. So we can use Pythagoras, and using Pythagoras we can go and say that this side squared, 2x squared, plus this side squared, x squared, equals 1. That's going to come to 2x times 2x, which is 4x squared. So that's 4x squared plus x squared equals 1, which means that, I'll just do it up here, 5x squared equals 1, and x squared must equal 1 over 5. Now I'm going to just keep that as x squared. I'm not going to square root it and say it's because the area of one of these squares is x times x is x squared, so the area of each one of these squares is 1/5, and altogether there's 8 squares, so our answer is 8 times 1/5, which is 8/5. That simplifies to 1 3/5, so the answer is B. Question 24. A new taxi firm needs a memorable phone number. They want a number which has a maximum of 2 different digits. Their phone number must start with the digit 3 and be 6 digits long. How many such numbers are possible? I think I'm just going to try and write out all the numbers. Or at least I'm not actually going to write out all the numbers. I'm going to start off with the obvious one. I've got a 3 here, and it could have 5 3s after it. So that's my first number. My next number I'm going to use a separate digit. I'm going to call that digit x, and it could be a 3, and it could be 3 3 3 3 x. But that x could go in this last place, it could go there, that's a 3rd place, 4th place, 5. There's 5 places that x could go. A total of 5 places that one x could go. And that x is one of the digits. It can be any of the digits. 0, 1, 2, can't be 3 because that would just repeat the top number there. So it's 0, 1, 2, 4, 5, 6, 7, 8 or 9. There's 9. So altogether there are 5 times 9, which equals 45 possibilities having a 1 digit with all those 3's. The next option is to have the leading 3 and have 2 x's, 2 other digits. So I'm going to put the 3, 3, 3 and XX there to start with. And I need to know how many different ways that can happen. If I just scribble it over here, I could have the 3 there, and it could be 3, 3, 3, X, X, or it could be 3, 3, X, 3, X, could be 3X, 3, 3X, it could be X, 3, 3, 3X. I could then have 3, 3, X, X3. This is just combinations. 3X, 3X3, X3, 3X3. Next, I can bring the x's there, so I can have a 3X, X3, 3, X, 3X, 3, 3, and finally I can have the X, X, 3, 3, 3. Overall I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different ways of having those x's. So that's 10 different ways, and those x's could be any one of 9 digits. So overall I could have 10 times 9, which equals 90 different combinations of 3 with 2 of the other digit. Now I can do the same in reverse. If I have 3, 3, 3x, x, x. Now this I must also have 10 times 9 equals 90, because it's the same as above. I've got, instead of 3 3's and 2 of the other, I've got 3 of the other and 2 3's. I must be able to arrange them in the same sort of way. And then I can have the option of 4 x's in there, so that's 3, 3, and it's be x, 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 x. Now the number of different ways I can have 4 digits of a different type and 1 3 must be the same as the number of having 4 3's and 1 of the other. So that's going to be 5 times 9 equals 45 again. And my last option is having them all as x's. So that's going to be 3 x, 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 x. Now there's only one way of having that, but there's 9 possibilities for those digits. They could be 0, 1, 2, not 3 again, because we've already had that up there. So that's times 9 there, which is 9. And don't forget, we've already had the 3's up there, so that's one of those. If we add all of those together, we get 280, which is answer B.